Hi, I'm Matt, and in this video we are going to go over states of matter and phase changes. So to start off, we are going to be talking about the three main states of matter. As many of you may know from younger grades, those are solid, liquid, and gas. Now, the reason I say main states is there are two others, but only under extremely rare conditions, and those are plasma at really high temperatures, and the Bose-Einstein condensate at really low temperatures. We're not going to go into those last two for the purpose of this video. The first state of matter we are going to talk about is solids. Solids have a definite shape and a definite volume, meaning they're going to stay in whatever shape they start in unless something is done to them, and they're also not going to change size without something being done to them. In a solid, the particles are arranged in set shapes known as crystal lattices, and the particles only have vibrational motion, meaning they move back and forth. Some examples of solids are computers, chairs, tables, and if we have solid water, it's called ice. Lastly, we're going to look at a particle diagram for a solid. You'll realize that the particles are all tightly packed together and touching, and they don't take the shape of the container, but they stay in a set structure, such as here, they're staying in a cube. Next, we are going to talk about liquids. Liquids have an indefinite shape and have a definite volume. The indefinite shape means they're going to take the shape of whatever container they're in. But the volume of the liquid will always be the same. And the particles have multiple types of motion, not just vibrational like the solid. They have vibrational motion, meaning they move back and forth, translational motion, meaning they move over each other, and rotational motion, meaning they turn and spin in the liquid. Some examples of liquids would be water or soda. If we look at a particle diagram of a liquid, we see that all the particles are on the floor and are taking the shape of the rectangle they are in. Lastly, we are going to talk about a gas. Gases have an indefinite shape and an indefinite volume because the particles spread out to fill the whole container. So the volume of a gas will be whatever the volume of the container they're in is. And the particles move in random straight lines, and some examples of gases are steam and air. If we look at a particle diagram for a gas, we see that the particles are spread out throughout the whole container and aren't very close to each other. Now that we've talked about the different states of matter, now we're going to talk about phase changes, or the transitions between the different states. Each substance has a particular temperature and pressure in which that substance changes from one phase to another. At that exact temperature and pressure, multiple phases of matter exist simultaneously. If we were to hold the temperature and pressure at that temperature for a very long time, the system would reach what's called phase equilibrium, and the multiple phases would be present in constant quantities. So if we were to hold water at 0 degrees Celsius and standard pressure, we would have both water and ice at the same time, and it wouldn't turn all to ice or all to water. The first phase change we are going to talk about is melting. This is when a substance goes from a solid to a liquid. For an example, we could see solid water or ice going to liquid water. You'll realize that an S in parentheses stands for solid, and a script L usually stands for liquid. Melting is an endothermic process, meaning energy or heat has to be absorbed for the process to occur. Next, we're going to talk about boiling, or more formally known as vaporization. This is when a substance goes from a liquid to a gas. If we look at the example of liquid water turning to gaseous water, or water turning into steam, we'll realize that G in parentheses stands for gas. Vaporization is an endothermic process as well, meaning heat or energy must be absorbed as the process occurs. You could remember this because if you want to boil water, you have to turn on the stove. You have to put something in for the water to boil or vaporize. Next, we're going to talk about a lesser-known phase change known as sublimation. This is when a substance goes from a solid directly to a gas and never becomes a liquid in between. For this, I use the example of solid carbon dioxide going to gaseous carbon dioxide. You could see this because this is what dry ice is. Dry ice is solid carbon dioxide, and when you see it steam up, that's it sublimating directly into a gas. Sublimation is also an endothermic process, as energy or heat is absorbed for the process to occur. Now, we're going to talk about the phase changes going the opposite direction. So we're going to start with freezing or solidification. This is when a substance goes from a liquid to a solid, or for example, water turns into ice. This is the opposite of melting. Freezing and solidification is an exothermic process, meaning energy or heat is taken out as the process occurs. That's why if you were to ever put your hand on the back of a freezer, it feels warm because all the heat is being taken out of it. Now, we're going to talk about condensation, which is the opposite of vaporization. This is when a gas turns into a liquid, or for example, steam turns into water. This is also an exothermic process, as energy and heat is released as the process occurs. The last phase change we are going to talk about, and probably the least known one, is deposition. This is when a substance goes from a gas directly to a solid, or for example, if steam were to turn directly into ice. This is also an exothermic process, and energy and heat are released as the process occurs. This is the opposite of sublimation. Now, I know that's a lot to remember, so I would suggest you copy down this diagram on the screen to help you remember. S stands for solid, L for liquid, and G for gas, and each arrow shows you what phase change is occurring. So for example, going from a liquid to a gas would be the yellow arrow, and that's vaporization. And all the way on the top and bottom, you could see which reactions are endothermic and which are exothermic. You'll realize that reverse processes, one's going to be endothermic and one's going to be exothermic. For example, melting has an arrow going to the right, and so does endothermic, so melting is an endothermic process. Its reverse process, solidification, will be exothermic. Now that we've gone through everything, here are 6 practice questions to help you test your understanding. Questions 1 through 3 pertain to the different states of matter, and 4 through 6 talk about phase changes and if they are exothermic or endothermic or not. At this time, I suggest you pause the video and try these questions on your own, and the answers will be provided for you on the next slide. The solutions are as follows. Solids and liquids have a definite volume. Liquids have a definite volume but an indefinite shape, and solids have their particles arranged in a crystal lattice. When we go from a gas to a liquid, it's called condensation and it is an exothermic process. When a gas turns into a solid, it's deposition, which is also exothermic. And then when we have a liquid go to a gas, it's called vaporization or sometimes boiling, which is an endothermic process. Hopefully you got these. If not, feel free to leave any questions you have in the comments below and I will get back to you as quickly as possible. Thank you so much for watching. Have a great day.